Good morning to everyone. I am Dr. Sumi MS. The name of the course is Electromagnetic Fields and today's lecture topic is Capacitance, Parallel, Cylindrical and Spherical Capacitor. On completion, the students will be able to define what a capacitor is, define capacitance and its unit, and also understand the different types and arrangement of capacitors. Capacitor. A capacitor is a passive electronic component that stores energy in the form of an electrostatic field. In its simplest form, a capacitor consists of two conducting plates separated by an insulating material that is called as the dielectric. This conventional arrangement is called a parallel plate capacitor consisting of two parallel conducting plates of any area separated by a distance. The symbol we use to represent a capacitor is based on the structure of the parallel plate capacitor, but this is also used for capacitors of all geometries. Let's assume that no material medium such as glass or plastic is present in the region between the plates. Here the capacitance is directly proportional to the surface area of both the plates and is inversely proportional to the separation between the plates. Capacitance also depends on the dielectric constant of the substance, if any, is placed between the plates separating them. When a capacitor is charged, its plates have charges of equal magnitudes but opposite sign, plus Q and minus Q. However, we refer to the charge of a capacitor as being Q and the absolute value of these charges on the plates. And here the Q is not considered to be the net charge on the capacitor. As the plates or conductors, they are equipotential surfaces and all points on a plate are at the same electric potential. Moreover, there is a potential difference V existing between these two plates. The charge Q and this potential difference V are proportional to each other and are given by the relation Q is equal to CV, where C is a proportionality constant which is termed to be as the capacitance value of the capacitor. This capacitance value depends only on the geometry of the plates and it doesn't depend on the charge or the potential difference existing between them. The capacitance is a measure of how much charge must be put on the plates to produce a certain potential difference between them. The greater the capacitance, the more the charges are required. The SI unit of capacitance is coulomb per volt. We can also express capacitance in farads, where 1 farad is equal to 1 coulomb per volt. A capacitor is a kind of temporary battery in an electrical circuit. When it is connected to a charging source, the capacitor stores this electrical energy. Once the charging source is disconnected from the circuit, the capacitor starts to dissipate the stored energy. An important measure in capacitors is the capacitance. It can be defined as the ratio between the amount of electric charge stored in a conductor and the electric potential difference across the conductor. Capacitance can also be acquired either self or mutually. Charging a capacitor. One way to charge a capacitor is to place it in an electric circuit with a battery. An electric circuit is a path through which charge can flow. A battery is a device that maintains a certain potential difference between its terminals. The three main types of capacitors are parallel plate capacitor, spherical capacitor and cylindrical capacitor. Parallel plate capacitor. A parallel plate capacitor consists of two parallel conducting plates of equal cross section that are separated by a fixed distance d. There is no limitation on the shape of the capacitor. Let us consider a parallel plate capacitor of two identical metal plates A and B that are carrying charges plus Q and minus Q respectively and are located at a distance d from each other. The capacitor is also connected to a battery. As given in this diagram, when connected to a battery, due to the potential difference, one of the parallel plates gets positive charges, whereas the other parallel plate is getting negative charge. Due to the potential difference between the charges in these two plates, an electric field gets induced between these two plates. The direction of this electric field is from the positively charged plate to the negatively charged plate, and it is expressed with an arrow here. Spherical capacitors. Spherical capacitors are formed by surrounding a solid or hollow spherical conductor with another concentric hollow spherical conductor. So instead of parallel plates, here we are having spherical shaped conductor which is surrounded by another spherical conductor. When connected to an energy source, both conductors will be charged equally, but the potential difference exists because of the difference in the radius of these two spheres. Cylindrical capacitors. These capacitors consist of a hollow or solid cylindrical conductor instead of a spherical conductor enclosed by another hollow cylindrical conductor. They are used to store large amount of electrical charges in a small space. Quiz questions on capacitance, parallel, cylindrical and spherical capacitor. What do you mean by a capacitor? Define capacitance and write down the SI unit of capacitance. List the different types of capacitor. Give a diagrammatic representation of parallel plate capacitor. Thank you.